pollution is very rampant in most of the cities and in the Indian cities, and so we were wondering what is the kind of root cause of this pollution, and is there a kind of solution to that. The conventional solution is always a sewage treatment plant, which has to collect the entire pollution to one point and then treat it, which is actually capital intensive, energy intensive, So we started with one of my co-supervised PhD students in Sri Lanka. So our first case study was in Kandy, Sri Lanka, which was in 2007, where he was studying one project which is a proposal for a JICA sponsored STP, and 4 years he did that PhD and still it did not come. But in the process we studied how wasteful an STP proposal can be, especially if it is kind of overseas funded. These are all kind of overestimated budget and the kind of overestimated expertise, all these problems are there. And then we found that it's so difficult for a city like Kandy. It's like any of our cities, narrow roads, and it's not like modern cities of kind of rectangular roads and things like that. So then it adds to a problem, and 70% of the cost is actually sewage laying cost than the plant, which is not really taken care in many of the projects. So then we studied Trivandrum. We found that there's a 107 MLD STP that's being set up there, but the sewage infrastructure is actually dating back to 1932. Like only 4 or 5% has gone up. So you have a 107 MLD plant, and that's only 36 to 40% is the sewage capacity. That means these are very wasteful projects. And we did studies in Ganga Basin also as part of the Ganga Basin management plan. It's very interesting that we calculate the costs actually. So in class 1 and 2 cities alone, it's like 11,000 MLD is coming out. So if you want to follow this paradigm, you need to spend 57,000 crores in capital costs alone. So then you can imagine the kind of running costs for such projects. So after spending this also, CPCB studies show that it's all suboptimal infrastructure. From this we started our studies on decentralized technology alternatives, where we studied DWATs in 18 contexts in India, and it came out that actually the technology is very, very interesting in the sense of capital costs and almost no running costs and no energy if needed, and very little kind of maintenance. And so we thought that the technology wise it's a very interesting innovation, but then it was failing at institutional levels was one, and wherever it is working at single institutions like hospitals or educational institutions. And so as a micro model it is very interesting. So our basic question was can this technology work at a town level? Then only we can have a kind of impact on our original question of pollution of water bodies. So our first pilot study was in Alibag in Maharashtra, where the first step was to kind of map the flows. So we thought we should actually kind of STPs work with thumb rules. You have so much of water supply and 80% of that becomes the kind of capacity of the STP. But here we thought it should be much more accurate. So what are the sources of pollution? We try to kind of calculate that, and then where is the flows coming in. So watersheds are the kind of physical units where natural flows happen. We mapped drains over it and made it into waste watersheds, and then we found that there are 9 waste watersheds in Alibag, So and then you have ready-made ponds or kind of water bodies or wetlands actually which kind of get this water imbibed also. So you can have actually kind of 9 decentralized systems, and then it can work in a way. Another advantage is that in an STP, it's an end of the pipe solution. Like you have to bring in the entire pollution of the city to one point and then treat it. Whereas here, it is more kind of dissipated. Second, you are also interested in reducing pollution. So do you need to kind of, in a plant, our calculation is this is it, and then the pollution and the population increases, and then we need a kind of another 20% increase in the plant in the next 15 years or so. Here you have to really plan and kind of reduce the waste at the source. So there should be those kinds of behavioral changes are also part of this what is paradigm. This was all done by students. Even in Alibag, we actually kind of asked students to kind of map this physical watersheds, waste watersheds, and then also the socioeconomic profile through a household survey. So there are physical units, and then there are overlaid socioeconomic profile of the village, which actually gives us sanitation zones. For example, Alibag has slums, then it has kind of more elite enclaves like multi-storied buildings, and then there are government quarters which are actually sparsely kind of populated. So so a city is a very disaggregated entity, and so there could be different types of interventions depending on the sanitation zones that you are talking about. We were all part of the larger people science movement in Kerala in the early 1990s, and so I was also kind of, I learned a lot being part of the decentralization exercises where Dr. Isaac was part of, and he was my teacher in Center for Development Studies. So this exercise was going on, the solid waste management exercise was going on. So we explored the possibility of kind of expanding this to liquid waste.